Hi, my name is Errol Hayward from the Portfolio Marketing team at Pure, and today we're going to talk a little bit about the effective use capacity, also known as EUC. So effective use capacity is the daily average of host-written data on Pure storage arrays, and it's used to calculate the billing for Evergreen One, Evergreen Flex, as well as Cloud Block Store. So Pure does not simply bill on provision capacity for these services. Even though this may seem like a simpler approach, it may not be fair to you since all volumes are thin provisioned. Instead, we bill for unique host-written data, which lets you take advantage of unique storage features like snapshots and volume clones without incurring huge costs. So what I'm going to do now is walk through a few examples of EUC to show you how it works. All right, so first we're going to take a look at an independent, unprotected volume where there's no snapshots or replication to consider. So when the host writes data to the volume, this data is represented as chunks of contiguous data called an extent. Alrighty? So let's take an example of where your EUC is equal to 3 megabytes. I'll refer to those as MIB from now on, okay? This is the amount of data where the host specifically writes data to the volume and is measured before any data reduction occurs. So now let's say the host overwrites one of the extents. Since we are still only storing 3 MIB, your EUC remains at 3 because we're still storing the same amount of data in the volume. But what if the host unmaps and deletes one of the extents? Well, now our EUC has decreased to 2 MIB. So now what if we cloned this volume, right? So I'm going to go back to the original volume with 3 extents, and I'm going to clone this volume. Our EUC actually goes back to 3, to match the original volume, and it remains at 3. And that's because, we only make changes to EUC if there are changes in the original volume. Let's say we overwrite one of the extents in the EUC, and then we add another as well. So in this case, the EUC increases to 5 MIB. And that's because we still have to store the original 3 extents and then also account for the 2 changes as well. And the same would apply to any changes that we would make in the clone volume as well. All right, so we just take a look at clones, but now let's take a look at snapshots, which are actually very similar. We're going to go back to our original volume here with our EUC at 3 MIB. Okay? So now, if we take a snapshot of this volume here. So our EUC is not affected. We only took a virtual snapshot of the volume here. So no changes have been written to the actual volume. But so once we start writing new data to the volume, let's say we write a new extent here, then our EUC increases because we're storing additional data on the original volume, and this extent increases from 3 to 4. More data stored on the original volume. EUC goes from 3 to 4. So now let's write some more data and take another snapshot. So we're going to write 2 more extents and then take a snapshot of this. So now our EUC increases to 6. So what if we were to delete one of the extents from the original volume? So actually our EUC wouldn't change, right? Because we still have to account for the 6 unique extents in the snapshot. So what if we were to overwrite one of the extents in the original volume? So our EUC would then actually increase to 7, because EUC is all about how much data is written to the array. So the number of snapshots doesn't necessarily impact the effective use capacity. It's just the amount of data that has to be stored. So I'm going to draw a couple more snapshots in here. Right? Boom, boom, boom. And then just to keep it consistent, we'll represent the overwrite the same way. And we'll do it again here. Another snapshot. And then again, keeping it consistent, we'll do the overwrite the same way. So now, with that, guess what? The EUC doesn't change, because all I did was make snapshots of the volume, of the original volume here. So we're still at EUC of 7. All right, so originally we talked about clones, then we talked about snapshots, and now we're going to talk about replication. And we're going to start with asynchronous replication. So asynchronous replication. So when we first start replicating, all the data is copied to a secondary array. So since we have 2 physical copies of the data, our EUC then is 6. So 2 physical copies of the data, EUC is equal to 6 MIB. Let's write 2 additional extents to the volume. And so our EUC increases by a factor of 1. So we added 2 extents, so our EUC now increases to 8. So it's not until changes have been snapped and replicated to the secondary array is when your EUC is affected. So now in this case, our EUC increases to 10. Of course, the more arrays, the more effective use capacity. So you can see how your RPO might impact your EUC, and that is because EUC is calculated on an average daily basis. All right, so the last example, which is kind of like example 3B, really straightforward. This is actually active cluster. So I'm going to draw a couple of volumes here. So the reason I say this is pretty simple is because with active cluster, both of your volumes will be identical. So the EUC is always double. So again, in this case, the EUC would be 5 plus 5 is 10. Okay, so those were a couple of quick examples of how EUC works. And so next, I'm going to show you our Pure One management tool, which is our AI-driven data services platform for storage management. And it's provided to all of our customers at no additional cost. And EUC can easily be tracked by looking at the subscriptions page or at the analytics section under capacity. For more information and documentation on EUC, feel free to go to our purestorage.com website, but also contact your account team. Your Pure Storage account team has a lot of information, and they'll be able to help you understand EUC a lot better. And they'll also be able to help you understand how to uncomplicate your data storage forever.